So Nvidia just posted a massive $68 billion quarter. But believe it or not, that's really not the whole story here. The true story is who exactly is funding this gargantuan AI build-out and why they literally can't stop. Welcome to our explainer. Today we're cutting through all the noise surrounding the AI infrastructure spending wave. We're going to look at what this money's actually buying, how to read the real signals in the market, and ultimately who captures the value. And joining me today to keep us totally grounded in financial reality is our resident skeptical analyst.
Hey, thanks for having me. Because look, while top-line revenue makes for great headlines, I am here to remind everyone that capex is not profit. And at the end of the day, somebody actually has to pay the massive electricity bills for all these chips.
Exactly. So is this capital cycle building a durable, untouchable moat for big tech? Or are we watching a bubble-like spending race that's just going to end in a huge overcapacity glut? Let's dive in and find out.
Okay, here's the high signal framework we'll be using today. First, we'll hit the $68 billion quarter, then the capex moat, map out the winners and the pressure, dive into the profit problem, expose the power limits, and finally look at cycle signals.
Right, let's get into Section 1, the $68 billion quarter.
For the fourth quarter of fiscal 2026, ending January 25th, Nvidia reported a truly record-shattering revenue of $68.1 billion. Think about that. That's a 73% year-over-year growth. This number really sets the stage for the massive real-world stakes we're dealing with here. We aren't just talking about theoretical tech enthusiasm anymore. This is actual hard capital flowing through the global economy at an absolutely unprecedented scale. It impacts everything, from the digital tools you're using at work right down to the broader financial markets.
Now, out of that $68.1 billion, a staggering $62.3 billion came directly from the data center revenue alone. And that's an absolutely crucial distinction. We aren't talking about consumer graphics cards here. This figure represents the actual physical plumbing of modern AI. Nvidia is basically supplying the heavy machinery for this revolution. But that sets up a really big question. If one part of the stack, the hardware supplier, is seeing this kind of historical profitability, why is the rest of the ecosystem so incredibly eager to sign up for a spending spiral that could last for years?
Which brings us to Section 2, the capex moat. So why are the big hyperscalers so incredibly eager to drop hundreds of billions on all this infrastructure? Well, the old tech playbook used to be build better software models and you'll win the users. But today, the reality is that building massive compute capacity is literally the only way you can ship these advanced AI products in the first place. When the supply of chips, power, and networking is super constrained, your capital expenditure, your capex, becomes the ultimate bottleneck. The companies willing and honestly able to spend the cash can translate that hardware into speed, reliability, and guaranteed enterprise performance. And that ultimately leads to deep customer lock-in.
Even Nvidia themselves are calling this current moment an agentic AI inflection point. They're pointing out that AI is rapidly moving from just simple chatbots to fully autonomous agents that can actually take action. Imagine an AI that doesn't just suggest an itinerary, but actually books your flight and files your expense report for you. The whole industry views this as a totally fundamental shift, and it's one that requires an absolutely unprecedented amount of capital to pull off.
Moving on to Section 3, winners and pressure. So who's actually making money here? Let's break down the tech stack. At the foundational layer, the clear-cut winners right now are the companies selling those scarce hardware blocks. So chips, GPUs, high-end networking, they're capturing immediate value. But as you move up the stack to cloud platforms and enterprise apps, things get a whole lot more complicated. Those layers face intense operational pressure. Take enterprise apps, for example. They might actually be looking at margin compression because simply adding AI features spikes their inference costs. That's the actual computing power required every single time a user asks a question or triggers a task. It's forcing these companies to completely redesign their workflows just to try and stay profitable. And sitting right in the middle of this stack are your cloud platforms. Sure, they generate revenue by selling managed AI services, but to do that, they have to eat some massive, unavoidable costs. Specifically, the depreciation of all that incredibly expensive hardware and the literal, physical cost of power. All right, this is exactly where I need to jump in. Section 4, the profit problem. Let's pivot from all this top-line hardware hype to the brutal bottom-line reality for the companies actually buying this stuff. Look at the incredible tension playing out right now. On one side, massive capital expenditure is just rocketing up as companies desperately race to build capacity. But on the flip side, you see the direct result of that, extreme pressure on free cash flow. Sure, Nvidia's numbers look fantastic, But hyperscalers dropping hundreds of billions of dollars isn't automatically a great thing for their own balance sheets. In the near term, it can absolutely crush their free cash flow.
I mean, just look at the staggering 2026 capex guidance figures we've seen recently. Amazon is guiding for around $200 billion. Google is estimated to be between $175 and $185 billion, and Meta is looking at somewhere between $115 and $135 billion. This really puts into perspective the sheer volume of cash just pouring out of the hyperscalers' balance sheets. That is real money out the door today, with the very desperate hope of generating returns tomorrow.
Basically, what we're looking at here is a classic prisoner's dilemma, and it's a super dangerous game. If these hyperscalers decide not to build this capacity, they essentially guarantee failure, because enterprise customers are going to flock to whoever can provide reliable AI at scale. But if everyone races to build at the exact same time, they run the massive risk of overbuilding, and that would severely compress profit margins across the entire board.
Which brings us to Section 5, Power Limits.
Because, the risks aren't purely financial here. There are literal physical laws governing this digital arms race. And this is the big question that really challenges that pure hardware narrative. Who exactly pays the electricity bill? You can go out and buy $68 billion worth of cutting-edge silicon, but at the end of the day, a GPU that you can't power is just an incredibly expensive paperweight sitting in a dark warehouse.
Skeptical analysts, power and networking are the true governors of this entire cycle. Operational bottlenecks are what dictate real-world success right now. You have to figure out site selection, lock down massive power contracts, engineer advanced cooling systems, and focus heavily on reliability engineering. A cluster of chips without the power to run them, or the networking fabric to actually connect them, is basically wasted silicon. The competition has totally shifted from who has the best chip to who can actually operationalize a data center the fastest.
All right, Section 6, Cycle Signals.
So, with billions of dollars on the line and power grids basically maxed out, how do we track if any of this is actually working? Well, here is a highly effective 3-column framework you can use to judge whether this massive infrastructure spending is actually translating into durable business value. Column 1 is capacity. What are they actually building? Are we talking GPUs, data centers, custom silicon? Column 2 is utilization. Can they actually keep that infrastructure busy, either with massive enterprise demand or their own internal products? And finally, column 3 is monetization. Do they have a realistic path to charge more for this compute than it costs them to operate, whether that's through premium pricing or highly differentiated services?
Exactly. And here's how you can use that framework to spot the real danger zones. If you see companies aggressively building out capacity without securing the utilization to keep it busy, that equals overbuild risk. It's essentially a multi-billion-dollar bridge to nowhere. But conversely, if you see high utilization but zero monetization, well, that equals margin compression. You might be incredibly busy, but you're losing money on every single compute cycle. For sure, the true long-term winners in this cycle have to prove they have all three.
And finally, Section 7, Final Judgment.
Let's take a step back and look at the macro view of what we've covered today. Is this massive 2026 capex cycle totally rational, or is it just a gigantic overbuild? Well, the truth is, for the current market leaders, it's actually entirely rational. Compute has effectively become the new strategic input of our era. It's very much like what oil was to the industrial age. You absolutely have to secure it. However, history strongly proves that not every invested dollar earns a return. Some of these multi-billion-dollar investments are going to look brilliant down the line, while others will undoubtedly look like a brutal overbuild in hindsight once these supply constraints finally ease up.
Which leaves us with one final, pretty provocative question for you to consider today. Look at the staggering numbers, look at the very real physical limits of our power grids, and look at the massive amounts of cash just pouring out of these balance sheets. Is this 2026 capex arms race simply the inevitable phase of building a permanent, untouchable moat for big tech? Or is it a trillion-dollar prisoner's dilemma that inevitably ends in total overcapacity? Take the framework we shared today, track the capacity, utilization, and monetization for yourself, and you decide. Thanks so much for joining us for this explainer. Keep learning and stay focused out there.